Today, 1500 volt inverters and DC connected storage. My guests today are Jonathan Helmuth and Eric Every with Yaskawa Solectria. We're going to be talking about Solectria's 1500 volt line of inverters and a DC connected storage combination solution that they are going to market with in partnership with Dynapower. Welcome to the show, guys.
Hey, thanks for having us. Appreciate it.
Pleasure to be here.
So I got to know Solectria a couple years ago when the 1500 volt inverters were still in the planning stage. And of course that works really well. The 125 kW inverter, of course, was part of that product line. And that works really well for a 2 megawatt AC solar project, which we have a large number of projects happening in Illinois that fit that bill. And so I'm looking forward to learning more about your product line and now your DC storage solution. So let's get into it. But first, give us a little bit of background on yourselves. Why don't we start with you, Jonathan? How did you get into solar, and what keeps you up at night?
Yeah, thanks. So I started out, I was actually the production manager for a green smart metering company. So we manufactured electrical meters, water pump meters, oil meters with built-in Wi-Fi, cable modems, Zigbee, etc. And then I was hired at Solectria to run one of their production lines. And then I grew from there to running all of production, and then moved into sales, which I've been doing for the last 6 years. So it's been a wonderful company to work with. I'm now in my 11th year here. And I guess what keeps me up at night is, I think that the renewable energy industry is just so exciting to work in. There's so much promise. There's things change constantly. There's always new hurdles and things for us to adapt to as policies change, as national electrical code changes, and we have to quickly adapt and overcome these difficulties as an inverter manufacturer and energy storage supplier. And so it's really fun that there's never a dull moment, I think, in solar. There always seems there's some new challenge or something new to learn about, especially with now the advent of energy storage. So that's I guess my take on it. But I'm really excited about the energy storage part of it, and I think it's going to be the future for the renewable energy industry, is being able to harness and capture and then dispatch that energy when you need to, as well as being able to do a number of things the utilities are interested in, is strengthening the grid and doing a lot of other fun stuff, which Eric can go into more detail with.
Yep, sounds good. And storage is such a hot topic, and because storage can offer so many different value stacks or services, both for the customer and for the grid operator. So it's still very early days. We're going to see so much innovation in this space in the coming years. So it's very exciting. How about yourself, Eric? Tell us a little bit about yourself.
My name is Eric Every. I'm calling you today from Lowell, Massachusetts. I've been with Yaskawa Solectria Solar for about 9 years. My current role right now is product manager of our 1500 volt string inverter solution, as well as our energy storage deployments. So the main purpose of my product management role here is to make sure that our customers find value in the equipment that they're buying, and that the equipment that we're selling has all the right certifications and features, so that it's useful when connected to the grid.
Yep. And so let's get into the product line a little bit. Give us the high level. What is the 1500 volt product line, and what, inverter voltages have been going up. And
that's a really good point. So we have a phrase that we throw around every engineering meeting, and that's current drives cost. And the point of that is, the more current that a device has to run to hit the power level that you want, the more all that material costs. So your bus bars have to get bigger, your capacitors have to get bigger, your IGBTs have to get bigger, your inductors have to get bigger, the enclosure has to get bigger to fit all the stuff in it. It gets heavier, it gets more expensive to ship. So everything that we can do to reduce the amount of current that we have to control through our switching power electronics reduces the overall cost. And one of the dials that we can turn to make that happen is cranking up the voltage. So if we want to, our flagship product right now is 166 kilowatts. We have a 600 volt AC output. If we wanted a 480 volt version of that, it would, to hit the same power level, the 166 power level, would cost about 25% more. So for the same power, we can cut the cost by 25% by boosting the voltage. And we have two dials there. We have the AC voltage and we have the DC voltage. The AC voltage, we're kind of limited here in North America at 600 volts, kind of with all the ratings and certifications for typical electrical distribution gear. So wire switchboards, disconnects, UL kind of maxes out at 600 volts AC. If you want to go higher than that, there's other ratings that you can get, but now you're in like a 2000 volt class, and it's very hard to procure that equipment. It's very expensive. It's kind of a niche specialty item. You can't just go down to your local electrical distributor and expect it to have them in stock. So that's why we picked in that 600 volts. And 1500 volts is, same thing with the modules. It's kind of the voltage that a lot of module manufacturers are most technically advanced and comfortable doing. There's some strange things that happen at the semiconductor level at those higher voltages. So, pushing that voltage to 2000 volts or 2500 volts, it's possible, but there's some reliability issues that start to creep up almost at the molecular level with that high voltage physics that goes on in there. So 1500 volts is kind of where the industry feels the most comfortable. Same thing, current drives cost. If we could get 2000 volt strings, 2500 volt strings, there's lots more that we could do to continue to reduce cost in the system. Voltage is basically free, right? All you have to do is make, the insulation on the wire a little bit thicker, space bus bar a little bit further apart. So, our preference is to kind of push the voltage higher and higher to keep keep releasing product that has lower costs, which then, turns to lower installed cost of the project and lower levelized cost of energy for the off-taker.
Most rooftop is still 480 volt, right? Most
yeah, rooftop
inverters...
commercial is 480 volt. I don't think that will change anytime soon. National Electric Code has a limitation for rooftops that's
right,
maximum 1000 volts. So when we do the power conversion electronics, a 1000 volt array will typically run at like 650, 750 volts DC. So for us to do that inversion into an AC waveform, the typical DC voltage there kind of has to match the peak of the AC waveform. So if we want to avoid adding some costly electronics to boost the DC voltage up to get the right AC waveform, 1000 volts really makes sense for 480 volt systems. That and most, I don't want to say every building, but most buildings, their power distribution equipment in the building is already at 40 volts.
Right. So what we're talking about is with 1500 volt it's all ground mount.
Yes.
And small utility to large utility scale, right? Jonathan, what are you seeing in the market though? Let's give our listeners a little bit of a background on what's going on here in the Midwest and how quickly is this 1500 volt technology being adopted?
Yeah, Tim, that's a great question. So we've seen just huge growth in the Midwest, which is awesome to see. I handle the Midwest. I'm the regional sales manager for Yaskawa Solectria Solar, so I spend a fair amount of my time out here or out there, and it's been great to see so many states, have new incentive programs and release new programs that will that push the adoption of PV and energy storage. As far as what we've seen, it's been a very quick transition from 1000 volt DC to 1500 volt DC for ground mount installations. And one of those main reasons Eric was talking about is cost. And when you move up to a higher DC voltage, there's advantage is not only that the inverter costs less, but there's also a lot of balance of system considerations where you have less voltage drop, so your conductors don't need to be as large. So overall, it's a much better building block, and it lowers the cost for the entire system, which means more systems can get installed at a higher rate, which I think is what everyone wants. Yeah, just like when we went from 600 volts to 1,000 volts, I think the change was as fast, or maybe even faster, 1,000 to 1,500. Every ground mount project we're looking at and we're talking to customers about is based around 1,500 volt inverters and 1,500 volt energy storage. For all those reasons, that it's just a more economical way to build the system. And you're also building it with the latest technology. So you're using the newest designs from manufacturers such as ourselves, with the newest built-in security for the grid and for grid stabilization.
And in terms of the Midwest, of course, we know about Minnesota, which has a community solar market. These are 1 to 5 megawatt projects. We have Illinois, which has 111 2 megawatt AC projects getting built this year and next. What other markets do you see coming to the fore?
Yeah, that's a great question as well. So what we see a lot is utilities. A lot of utility players are very interested in solar and PV and energy storage. Some of that's mandated by their ratepayers, but a lot of them have programs in place and goals in place where they want to hit X amount of renewable energy, some of that being PV. So we work with a number of customers and utility customers in the Midwest, Alliant in Wisconsin, NIPSCO, IMPA in Indiana, Consumers Energy in Michigan. We've been seeing a huge amount of interest and growth from the actual utilities themselves. Us as an American manufacturer, I think brings a lot of value add to the table, as well as that we manufacture, in Illinois, right in the Midwest. So you have the support of the entire organization for them right there. We're very proud to say that we're the only inverter on the market that ships with an American flag on it that says Made in America. We're fully Buy American Act compliant, USMCA compliant, etc. So I think that also holds a lot of weight with the utility companies. We also spend a huge amount of our time on our network security. So we were invited before for COVID and everything. We went and have been invited many times to speak on international panels and international trade shows to discuss our networking security. Everything we use is AES 256-bit encrypted. So when you do your online banking, so what the NSA mandates that the banks use is that same level of encryption. So whenever you go to a web page and you see the padlock in the upper left-hand corner of your browser, that means you're using that same encryption. We also have a number of companies we work with, and maybe Eric, you can go into more of our network security and some of the future things we have going on. But that I think the fact that utilities, especially when they see how much PV is being installed, how much energy storage is being installed, both by themselves and their customers, that they really are getting concerned and understanding that, there we go, great, thank you so much, Eric, are very concerned about the network security. And as these assets become larger and larger and a part of their generation, they're very concerned about this network security of it. What can a hacker do? Can someone turn off a PV plant? Can someone mess with the frequency? Can someone really do some destruction and damage to our grid and also our national security because of it? Eric, I don't know if you have any more data.
And let's not forget that you are making these inverters in Illinois, in Buffalo Grove, in the Chicagoland area. So it's a Midwest product, and American technology. Solectria was a spinoff from MIT originally, right?
That's correct. Yep. You got it.
And that, of course, does give an added peace of mind, you know, when there's so much possible playing behind the scenes, right, with embedded software made in China. We install inverters made in China all the time, but if you have a extra security requirement, I would venture to guess that that gives you a leg up.
Absolutely. So, you know, being one of the only or the only inverter manufacturer for PV made in the U.S., you know, we get a lot of inquiries from projects that are Department of Defense or some sort of government funded project. So if you're putting solar on a military base, you know, you're doing a microgrid, you know, there's a lot of mandates right now for microgrid updates on military bases for energy resiliency. You know, having that cybersecurity built in is imperative to, you know, the security of the mission, right? So we're not really designing equipment for that customer specifically, but we have a lot of, you know, there's a lot of overlap in what our customers are looking for, the utilities are looking for, and what some of these DoD projects are requiring of us. You know, for example, we have this new wireless interface where when you're on site, you can take out your phone and your tablet and or your laptop, anything with a Wi-Fi connection and an internet browser, and you can, you know, connect to the inverters on site. And it really streamlines commissioning and, you know, diagnostics of equipment and trying to, you know, get the system configured. Incredibly useful during a witness test. But when we do a project like at a military base, they don't want any wireless, right? So we have to be able to shut this up. So a majority of our customers, let's say like 90% of the projects that we deploy, this is, you know, the greatest thing since sliced bread, you know, being able to take out your phone and figure out, you know, why is inverter 7 not operating the way that it's supposed to? Meanwhile, you got the utility witness supervisor looking over your shoulder to try to, like, you know, complete the witness test for interconnection. Really relieves a lot of the pressure there. So being able to turn that off is something that's available to all of our customers. The internet security, that's a top line item for us. We're in the midst of a DoD funded, a DoD funded project to essentially build firewalls and types of network security that's modular and deployable for a lot of these energy systems, whether it's PV or energy storage or wind. So we're involved in kind of the energy production portion of that. And then another thing is the 2030.5. So this is a new requirement in California where, you know, to participate in a Californian interconnection, you have to have sort of a network connection to a utility server. And what that does is it gives the utilities some level of control and also some telemetry information about how your system's performing, so that if there's some strange activity on the grid, they can curtail your system, they can activate some of the reactive power functions. And it seems kind of strange, you know, why am I giving the utility, you know, full access to my inverters? You know, why do I want to give them the ability to turn the system off? Why do I want to give them the ability to activate reactive power control? You know, why do they need to know voltage and power for every minute of the day? And it's the answer is grid resiliency, right? You know, they're at the point where, you know, if they don't start modifying how these systems behave on the grid, then they can't allow any more systems. You know, you look at Hawaii, you know, you'll go to some of these utility meetings and, you know, the people that the engineers there are very frustrated in how the prevalence of PV has really disrupted kind of the grid resiliency of the systems that currently exist. So it wouldn't be uncommon, you know, in the middle of the day for solar to be the #1 producer of energy in Hawaii, which sounds great, except you have all these rotating machines that can't really keep up and keep the voltage stable. So there has to be some systems in place keep the voltage and the frequency stable for everybody.
Tell us more about that, though. When you have high penetration of solar like you do in Hawaii, why does that become a problem for the grid operator?
So the PV doesn't really have any inertia, and it's a very intermittent power source. So as the irradiance changes, as clouds go over the array, the power changes instantaneously. Fractions of a second, you can go from, well, maybe not fractions of a second, but you can go from 100% to 0% in a very short amount of time, on the order of seconds. And if you have a rotating machine, like a traditional generator, to start that up, to go from 0 to 100 on that, that can take 15 minutes. And those are the fast ones, right? So it wouldn't be uncommon to take an hour to start one from cold and get it up to 100% output. So that kind of rapid variability doesn't pair well with kind of the slow nature of a lot of the existing power generation equipment. So if you're trying to maintain frequency and voltage and keep the lights on for everybody, and you have a resource that's up and down all day, every day, all your protection functions are firing faster than they should be. The control systems that are in place are designed to look at things over the course of, maybe like a 15-minute span or an hour-long span. And then if they catch it in a window in like that 1 second dip, then you've adjusted for something that only lasted for a couple seconds. And then once the transient passes, now you're in a worse position. You fired a protection function, a voltage changer that you shouldn't have, and the voltage is way out of line. So it can cause a lot of problems. And one of the ways that we can fix these problems, let me see if I got it, is these grid support functions. So when we talk about 1741 and 1741 SA, there's some new functions that all the inverters are required to have. And Solectria has been involved in developing and vetting these features for a number of years with DOE and EPRI. So now it's finally part of the standard where, every distribution connected customer can implement these. And this is voltage ride through, this is frequency ride through. So if the voltage sags or surges a little bit, instead of the inverters all just tripping off all at the same time, we can ride through and support the grid. Because for every kilowatt that you shut off, you have to support with a kilowatt from somewhere else. At every given moment, the load has to match the generation within a few percent, right? So if you have all the inverters all turn off at the same time, now you have, megawatts, potentially gigawatts of deficit of energy that you have to make up for with something else. And if it takes you 15 minutes to start a generator to get there, then that means that people are going to lose power.
Yeah. So as you were talking about high penetration of solar and the challenges it gives to the grid operator, it immediately occurs to me that, well, this is a great problem for storage to solve, battery storage, right?
Absolutely, yeah.
But is there a delta in how DC connected versus AC connected storage plays with the utility? And do utilities have strong feelings about AC versus DC connected?
It kind of depends on the application. So when we talk about DC versus AC coupling, AC coupling is a little more flexible in terms of how you locate your resources. So if you have a college campus or you have a microgrid scenario, here, let me pull up a slide here. Yeah. So if you have a college campus microgrid scenario, things where the solar can't necessarily be co-located with the energy storage, it absolutely makes sense to AC couple. And when we say AC couple, that means that there's two inverters. There's one inverter for the solar, and then there's one inverter for the batteries, which means that you have to buy two inverters to make this work. So a lot of microgrids do this. Military bases, college campuses, corporate campuses, microgrids, things where you're trying to spread out different assets on the amount of land that you have. So the AC coupling refers to the two systems get connected on the AC side. And that's in contrast to the DC coupled topology, where I put the batteries and the solar on the DC side of one inverter, and then have that one inverter manage all the inversion and export to the grid. So this is the tack that Solectria is taking here. There's some cost benefits. First and foremost, I only have to buy one inverter as opposed to two. So there's some hardware cost savings there. Granted, the inverter has to be twice as large as opposed to two, or let me rephrase that. So there's some cost savings here in the sense that you only have to buy one inverter as opposed to two. And we can do some power electronics on the DC side to match the charge and discharge voltages for the batteries. We have to manage that appropriately. So we have a charge controller specific just for the batteries. So the PV has the MPPT voltage. So as the irradiance changes throughout the day, we have to vary the voltage on the array to extract maximum power out. And that voltage that the inverter operates to do that will never be the correct voltage for the batteries to charge and discharge. So we have to have an intermediary there to manage the charging and discharging. So we call that a charge controller, essentially, or a DC to DC converter. So it's taking DC voltage on one end and converting it to a different DC voltage and managing the flow of current. So that's the partnership that we have with Dynapower. So they're providing that equipment for our customers. So we've done a significant amount of development work with them to pair our two systems. So we're providing the inverter part, our 1500 volt string inverter. We're able to pair that in a 500 kilowatt block. They provide their 500 kilowatt charge controller, and you have a relatively cost effective solution for DC coupled energy storage. Jonathan mentioned earlier that here in Massachusetts, we have in the SMART requirement, systems over 500 kilowatts are required to have energy storage, mostly for that grid resiliency issue that we talked about earlier. So the idea is that, we have this 500 kilowatt block. It matches well with not just Massachusetts, but, many states across the nation, and they're encouraging incentive programs to help deploy energy storage.
Yeah, as far as I'm aware, there are 3 states primarily that are offering incentives for storage now, right? Massachusetts, New York, and California. Are there others?
Yeah, Hawaii has a good program. There's a few states in the Midwest that are starting to roll out some programs. New Jersey had a good program for a while. We're starting to see more and more states deploy energy storage. Rhode Island, New Hampshire, Maine.
Okay.
Because they see the benefits, right? It's clean energy is just part of the equation, and kind of the when you compare the pros and cons of solar, a big item in the cons list is that it's very variable throughout the day. And when you need the energy most isn't necessarily when you're going to generate it. So we generate the most energy between 11 a.m. and 2 p.m. Where when you need it the most is probably 6 p.m. to 9 p.m. That's kind of the general system peak. Everyone comes home from work, they turn on their ovens, they turn on their air conditioner or their heat pump, they turn on the television and all their lights. It's kind of the end of the day peak there is 6 p.m. to 9 p.m., which you don't get any solar energy during that time. So how do I take a time period where I have almost too much, I hate to say it, but almost too much energy from solar and save it for when I need it the most? So I hate to say the word because it's so overused, but duck curve, it's worth a Google. And it's this concept of, from 6 p.m. to 9 p.m. is the system peak, and you have no solar resource in that time to support that with clean energy. But all throughout the day, from let's say 8 a.m. to 5 p.m., you got almost more solar than you know what to do with. So when all the solar turns off at the end of the day at dusk, how do you quickly ramp up all of your conventional generators in a very short amount of time to meet that system demand? And energy storage is a great way to do that. Traditionally, when you do that ramp, you're using the most expensive generation units. So, supply and demand and price are all very closely linked in, you know, the cost of energy. So as the demand goes up, the price goes up, which then incentivizes the kind of least efficient, most polluting generators to all turn on at the same time. So having energy storage, you know, I can take the clean energy that was generated at noon, save it till, you know, 6 or 8 o'clock p.m. and then dispatch it as a clean peak generator, as opposed to turning on some other conventional assets that are a lot more polluting.
Right. I'm going to share my screen and just show our listeners a picture of the duck curve here. It's, you know, this happens in markets that have a lot of solar or solar and wind, but particularly solar, right? So here's the blue line is the total load, and then after you get all this solar energy, which is the gray line,
Right, you subtract that off the blue, and then you get the orange line, right? So
right?
And it's called the duck curve because it kind of has the silhouette of a duck.
And so it's at that where the head of the duck is. That's where the storage has particular value, right, to attack this load and kick in, because then you've been able to charge with solar during the day, during the peak sun hours, and then the load is growing. You can see that the load is highest at 7 to 8 o'clock, and storage is wonderful for that. I mean, the other thing that we see happening is solar and storage, or solar and wind and storage, is being used to replace all kinds of traditional power plants, peaker plants, and just power plants, gas power plants, coal power plants, and the utilities are increasingly issuing RFPs like NIPSCO did, and you know, there's half a dozen of those now out there all over the country, and you know, utility scale storage. I think there's a 1,500 megawatt storage project happening in California now.
I believe it. Yeah.
I don't know if Solectria is going after that true utility scale market, but maybe you can address that.
Yeah, we'll get there eventually. You know, right now we're focusing on projects in kind of the 1 to 20 megawatt size. That seems to be our sweet spot in the market. You know, once you get up into that, you know, 50, 100 plus megawatt size, you know, the string inverters don't really make a whole lot of sense anymore.
Yeah.
You know, your central inverters, all, like, by scale of the system, become like your modular power source.
Yep.
What a lot of customers like about the string inverters is that it's a small modular power capacity. I can deploy as many of them as I need to hit my interconnection limit, and I can service them myself. Right. So we have parts in our equipment where, you know, the control board goes bad, the communication card goes bad, you know, a surge arrestor or something, you know, needs to be replaced. You just take the cover off the inverter, we send you a part in the mail, and you swap it, and you're done in 15 minutes. Whereas with the central inverter, you know, it's a little more of an operation, right? You know, there's a lot more energy available there. The training required to service that unit is a lot more complicated. So there's a higher risk to personnel. That personnel is more of a specialized training involved. And then there's parts availability, right? So that, you know, because we're deploying lots of these string inverters, we have lots of parts, whereas essential inverters are kind of a more specialty thing. So you gotta have those parts available. So I gotta get the right parts, the right people in the right place. And that can take some time if you're not prepared for it. So in a large, like 200 megawatt system, it's well within the budget of the project to have a Connex with some spare parts. And if you're a developer, you can, you know, have someone on staff full time to service that equipment. But if you're just doing like 1 or 2 megawatts, you know, 5 megawatts here, 10 megawatts here, you know, having one person dedicated to that array to service that array doesn't always fit in the budget of the project. You got to hire a contractor.
Sure. So let's talk about the C&I application for solar and storage, though.
Sure.
C&I is commercial industrial, and we, here in Illinois, we use batteries for capacity charge reduction in PJM and MISO, and frequency regulation, and a few other, but lesser stacks. We don't have very high demand charges,
Mhm.
whereas in California, storage is used to attack demand charges. And I get that. And unfortunately, most storage companies, whether they're software companies or service providers or sometimes even the hardware companies, they're still learning about the Midwest and how
Yeah.
we use storage. They want to use it to attack demand charges, and it just doesn't pencil.
Yeah. So
But
the demand charge is there to pay for the capacity to deliver you your energy. So, what is the cost of it? So it helps pay for the cost of infrastructure to be available for when you need it, right? It's like paying for, it's like when you buy a car, like you pay for the horsepower of the engine, and then your fuel cost to get around is your fuel cost. So very similar to your electric bill there. Your
yeah,
kilowatt hour cost is your fuel cost, with plus a little bit for wear and tear and maintenance, and then your demand charges, the horsepower of your engine, the capacity, the size of the wire, the distribution equipment, the size of the generator, the generators that have to run as backup in case another generator fails. We have these things called spinning reserves, generators just waiting to turn on, waiting for another generator to fail so they can step in and replace that. So that's kind of what your demand charge covers.
yeah. But let's get into your solution for
Sure.
C&I. If I'm a manufacturer and I'm thinking about installing a solar array, then I see and then we offer them a solar and storage solution. They can use the ITC on the storage, so that greatly enhances the ROI of solar plus storage. And then, of course, there's all these other value stacks that we've started to discuss. But give us the overview of the value proposition for DC coupled storage.
So first off is the cost, right? So I mentioned, one inverter versus two inverters. So if you were to do AC coupled, you have to buy two inverters, and then there's an interconnection requirement where, if you're constrained on how much power that you can connect, it's not uncommon for you to look at, the two inverters. So you got two 500 kilowatt inverters. You're like, all right, so I got two 500 kilowatt inverters, one's battery and one is PV. That's a megawatt total. And if your interconnection limit is, 600 kilowatts, then you're over the limit. But that's not how people would run that AC coupled system, right? You would typically have some controls to curtail the total throughput into the local distribution network. So if you can't articulate or you can't demonstrate to the protection engineer that's looking at that project, they'll want to bill you for the interconnection based on a megawatt as opposed to 500 kilowatts. So when you have a DC coupled storage solution, all of the conversion, all of the charging and discharging is managed on the DC side. So the utility will only see that 500 kilowatt inverter as the interconnecting device. So that acts as the bottleneck for the system and relieves a lot of the control overhead for balancing the charging and discharging. The second thing there is it helps a lot with the ITC accounting requirements for getting your batteries discounted through the ITC. So the way that I understand how I'm not a tax attorney, but the way that I kind of understand it here is that if 100% of your charging to the batteries comes from energy from solar or a renewable source, then you get to discount 100% of your batteries through the ITC, which sounds great. But let's say I don't do that. Let's say I charge, the batteries from 25% from the grid and then 75% from the solar. So I have to count my ITC savings by 25%. because 25% of the energy came from the grid. And I think I'm allowed to do that up to 30% grid charging. So which means that 70% of the energy has to come from solar. And a lot of these smaller developers are a little bit uneasy about, keeping track of all that, doing the accounting, making sure that they're not, violating the tax rules there. That, and majority of the time, 100% solar charging will meet your needs. So, why would I want to risk discounting my ITC to get energy from the grid where I may not necessarily need to do that? So kind of for the first year of our energy storage product here, will just be solar charging only, taking all the energy from the grid, taking all the energy from the solar array and dumping that into the battery, whatever's not converted through the inverter. So we call that DC peak recapture. So generally, if I have a 500 kilowatt inverter, it wouldn't be uncommon to have, 600, 700, 800 kilowatts of PV connected to that. And then when I add storage, I can take the energy that the inverter wouldn't normally be able to process and divert that into the battery and then use that for something else. I can discharge it later in the day. I can save it for tomorrow. I can save it for a rainy day. I can save it for a demand response signal, which is where the utility would compensate me for extra energy in a time where energy gets pretty expensive. So it's a way for them to kind of control their costs, and then you get a financial benefit for helping out. So that's kind of the major items here is, cost, one inverter versus two. You got to get a charge controller, but that charge controller is less expensive than an inverter. It doesn't have to have anti-islanding. It doesn't have to do AC conversion. The amount of power electronics is a lot more simplified. So it's a good way to kind of keep your costs under control. It helps with the interconnection in the sense it's one inverter as opposed to two, and you get the DC peak recapture. So it's, some customers will call it free energy. It's not really free because you already paid for the array, but it's a way to harvest more energy out of the PV system. Part of the cost of interconnection when you buy, the transformer and you place all the poles and you run all the wire and you do all that interconnection work, a highlight item of that is back to current drives cost is the kilowatt capacity, the current capacity of, the transformer and everything else. So if I'm designing for like a 15-minute peak at noon, I have to build all that equipment to carry that current at that 15-minute peak. But once you add in, a larger array, more energy than the inverter can process, you kind of square out that bell-shaped curve, have a longer peak at the top, and then you add energy storage and it gets even flatter. So now I'm leveling out the cost of all that interconnection equipment, the transformers, the wires, the poles, everything else. So it's a great way of improving your levelized cost of energy, which is, great for everybody.
Yeah. And so what is the downside of DC coupled? Because we just don't see a lot of that, or we don't feel pull through demand for that yet. We're curious, we want to understand, but are there things that we can't do with a DC coupled system that we can with an AC coupled?
Yeah, it has to do with like physically co-locating equipment near each other.
Mm-hmm.
So if I have a large array, but I want my battery, and I want a large battery system, and I want that battery somewhere else, you can't really do DC coupled storage with that. So DC coupled storage works really well for, an existing solar array or a new construction of a solar array. But as I mentioned earlier, if you're doing a college campus, a military base, a corporate campus, some sort of microgrid in a community where I want batteries in separate places, as opposed to where the inverters are, it's a great solution.
And that's because you have to avoid the line losses.
Yeah, exactly. And it gets expensive, right, to run long DC wires all over the place.
Mm-hmm.
There's also some resiliency benefits in having AC coupling, which is why you'll see them in microgrids a lot, where if you have a power electronics failure in a DC coupled inverter, a traditional DC coupled inverter would be like a 500 kilowatt monolithic block or a megawatt monolithic block. Then you lose everything. You lose the energy storage and you lose the PV production capacity. But with AC coupled, you kind of hedge your bets a little bit. So if you do have a power electronics failure, you get one or the other. So if the PV inverter fails, at least you have energy storage, or if the energy storage inverter fails, at least you have the PV. So there's some resiliency benefits there. So one of the ways that we kind of combat that a little bit is in our energy storage solution, we run 3 inverters in parallel. And I'll show you what that looks like here.
Okay.
If I can share my screen. So we have our 166 kilowatt inverter. And what we do is we take 3 of them and we put them together on the same DC bus. So I don't know if you can see this on the, there we have the Solectria 166. So that's our flagship PV product. We make 2 small modifications, one to the control board and one to the DC disconnect to make it our energy storage capable unit. We put 3 of those in parallel. Normally for PV, if you put a string inverter on the same DC bus, you could damage the inverter. You can blow out the IGBTs, and it's not a good thing. But what we're doing is we're synchronizing the units. So we have a communication cable that goes between the 3 inverters that synchronizes when the IGBTs actually switch. So if you didn't do that, the differences in voltage between the different inverters can drive current between the 3 inverters. We call that circulating current. And if that circulating current gets bad enough, you can damage the IGBTs and leads to an inverter failure, right? So by synchronizing the switching to all happen at the same time, we drastically minimize that circulating current and create a stable operating network. And by doing so, it builds in some resiliency into the system. So if we have a power electronics failure in one inverter, we still have the other 2 inverters that are able to operate. Even if we had a double power electronics failure, 2 inverters go down, that 3rd inverter can still provide some capacity. So for a lot of these customers that are looking to do, demand charge management, or even some of the clean peak standard, or something where, the finances for the month hinge on discharging your batteries in an hour or less time frame, that like 1 hour out of 30 days, that's your goal to hit your financial target for the month. If you have a power electronics failure during that short window, then you lose out on the revenue for that month, or you lose out for the benefit for that month. Potentially for the whole year if it totally goes sideways, right? So having those 3 inverters with that resiliency built in provides some assurance to the project owner that okay, so if I do have a power electronics failure, at least I have 2/3 capacity to get me as close as I can to the target that I'm trying to hit.
Mm-hmm. Yeah. So, I mean, one of the cool things about storage is that it can have a multiplier effect on the ROI of a project. We see a multiplier of as high as 5x when it pencils nicely. So that's why we say storage is the holy grail of solar, for the reasons we've already discussed, but also for the ROI here in primarily in PJM territory, Northern Illinois, where we're doing quite a bit of solar and storage now.
That's excellent. Yeah. And we're seeing costs of batteries fall every day, which just makes more projects more viable, right? But you really have to have some structures in place. The batteries aren't going to pay for themselves unless there's some incentive programs in place, and those incentive programs should be in place because it alleviates a lot of the system congestion issues. It helps with the environmental aspect of the pollution and emissions, and it helps keep those most expensive generators from operating, which helps lower the cost of energy for everyone. So it absolutely makes sense that these incentive programs are in place. And I'm glad that there's some infrastructure there to encourage that.
Yeah, we don't have state incentives for storage yet. So that's coming. Our governor just released a report
Oh, good.
on where he wants to see Illinois moving, and that includes specific incentives for storage and EV infrastructure, and of course renewable energy. So it'll be a few years perhaps before that is fully baked and integrated into the law of the land, but it's coming. And we're also expanding our RPS to 100%. We have a 25% RPS today in Illinois. Certainly within the next couple of years, we will have 100% RPS.
That's a fantastic goal. Yeah.
Yeah, I mean, over 100 states and cities in the U.S. have now set 100% RPS goals of various flavors. And so it just, you don't feel very special with the 25% RPS anymore.
No. Yeah, and it's one of those things where everyone can get behind, because the jobs it creates, it improves the infrastructure for everybody. It's a win-win for all.
Yep.
So Tim, on the projects that you're working on, what are you seeing as needs in energy storage?
Well, for one, it only pencils in about 10% of the cases that we look at. You have to have time of use rates to really make storage pencil.
Mm-hmm.
And I'm no expert at doing that analysis. We partner with a company called Intelligent Generation here, which is based in downtown Chicago. They are a spinoff from IIT, and they truly are experts at value stacking storage in PJM and MISO. We've just done our first large MISO project. We've done a 2 megawatt storage and solar project in central Illinois, and then we've done a handful of these projects in northern Illinois in PJM. And so of course the ITC helps a lot, and hopefully we can keep the ITC around or expand the ITC for solar and storage. Right now we don't have a storage specific ITC, right? It's just tagging on to the solar ITC, but yeah, it's still very early days. And I mean, we have a battery at Continental. We have a solar array on our roof and a battery in our basement, and we're doing frequency regulation. And while that's not bankable, because that value floats, it's still non-trivial and worth it. And so if you can make the capital expense, that's the largest hurdle for storage today, as I see it, is just it basically doubles your CapEx as you bring storage into a project. If it's if storage works, and then when it works really well, you're shortening the payback period from 5 years for solar alone. With RECs, we have a 5-year payback. It varies, right? Because every customer pays a different rate for electricity. We're a deregulated state, so it can be as short as 4 years, and it can be as long as 6 years. And then when you add storage, it can be as short as 3 years. So that's the beauty of it, and away we go. Now we have noticed that some developers are making their community solar projects storage ready. And NexAmp is one of those companies. I don't know if you guys have worked with NexAmp at all. They're from Massachusetts, right? So they're in one of the hot storage markets, so to speak. And that's kind of the way we see things. And but if you're not working with Intelligent Generation, we should definitely connect you guys, because yeah, I'm curious what they make of this DC coupled. They're certainly aware of DC coupled. They're some very savvy engineers there at IG, as we call them. But
yeah, we'd be happy to talk to them.
Great. I'll make an intro for you.
Fantastic.
No problem.
So that 3-year payback, that's a huge relief, right? To to go into a commercial customer and say, oh, you don't make your money back for 6 to 7 years, that's a hard sell. But if you can go in and say, in under 4 years, you've made your money back, and then after that, it's 100% savings.
You would think it would be like a complete no-brainer, but unfortunately, it's not. The challenge is that these are companies that are making things, and they have many other things going on in their business that require attention and capital. That's just the nature of the beast. Solar and storage is wonderful, and we, of course, as a solar installer, think it's the best thing since sliced bread. But it competes with the basic business model of most of these companies, and then the other thing is that CEOs are really looking for a 3-year payback many times on any infrastructure upgrades that they make, like installing a new line or building a new facility. And so I've seen many a solar project shot down because it was not a 3-year payback. And while we do see, the bleeding edge thought leaders are getting into storage, it's still just a very small fraction. And the vast majority of these business owners don't truly understand storage yet. It's, solar is very new here in the Midwest, period. And storage is even newer for most applications, not for UPS, of course. We build data centers at Continental, so we're very familiar with the data center world. And of course, there's transition going on there from lead acid to lithium ion, like everywhere else. And that's cool. I don't know if are you guys playing in the UPS world?
Currently, no.
Yeah, but we work a lot with Tesla, but that's a very dynamic landscape from what type of storage we're working with.
Understood. Yeah,
Well,
but I totally understand what you're saying. Where you come to a business owner and you say, hey, if you spend several $1 million on the solar plus storage system, we can save you money. What that same several $1 million, like what are other ways to spend that can have a little more, it's a little more relatable to what they're currently doing, and like you said, expanding a line or bringing in some automation or something else. So that's what you're competing against. And I could see how that would be a little bit of an uphill battle. But it sounds like you're able to find customers that value that and want the energy and want the solar plus storage, and that's fantastic.
Yeah, and they tend to be manufacturers. There's a variety of reasons there, but there are potential value stacks that manufacturers have, like avoiding uncontrolled shutdowns.
Right.
The battery can give you ride through. These are all 2 or 4 hour batteries. They're not long duration, but for short duration they're great. And
if you only have an 8-hour shift, right, and it a 4-hour duration at least gets you half the day, or at least long enough to not have a surprise shutdown. Gives you 2 hours to figure out how to ramp everything down. Yeah,
we see, for example, the injection molding industry, where an uncontrolled shutdown can be very costly, because then they have to clean out all the machinery. And so for a large manufacturer, one uncontrolled shutdown could cost $50,000. And so if you have a couple of those a year, that adds up quickly. And so that's where we've been getting some traction, but we want to get more. We love doing solar and storage. And so we'll have to get Solectria in to give a lunch and learn on the value stack, or just comparing it, because we're not very familiar with DC coupled. So we have a lot to learn. What else about your offering should we discuss today? We're almost out of time, but I really appreciate you guys coming on the show. If there's any case studies that you wanted to reference, I welcome that opportunity. And
there is one project that I want to talk about.
Yeah, I was just gonna say, is that the Toledo project by any chance?
Yeah. So this one, it doesn't have storage. We're just about to add storage. So they haven't bought the batteries yet. They literally just did some pre-commissioning turn-on tests. Um, so this is the Overland Solar project. So this is a project that is developed by the Toledo Community Foundation as a nonprofit. So Gem Energy kind of did the engineering work pro bono. Solectria donated the inverters. First Solar donated the modules. So they were able to develop this system as a way to sell energy to local manufacturers. So right across the street from this plant here is the Dana manufacturing plant. So they're making a lot of driveline systems for Jeeps, and I think some electric vehicle components as well. So the community foundation sells the energy to Dana and a few other local manufacturers in Toledo. And then they use the revenue from that system to fund the community improvement projects that the community foundation is known for. Kind of what they're most famous for is a program where they figured out that a lot of like teenage pregnant women would not go to the doctor, and one doctor visit would cut the risk of issues during pregnancy by 50%. Mm-hmm. So they paid a bunch of nurses to march around Toledo and knock on doors and find young pregnant women and give them a free doctor visit or several free doctor visits. So they say like, hey, we'll give you one and we'll give you a couple more if you keep coming. And it solved a lot of problems with kind of like newborn health issues. And since they've done that, the CDC is now implementing this program nationally. So the first place to do it was Toledo, through the Toledo Community Foundation. So that's just one of the things that they do. They do lots of things to help improve the community there. Obviously, with kind of the shift in manufacturing out of the United States, Toledo has been one of the cities that's been hit hard most by that. So having a community foundation that's committed to revitalizing the area is a very noble and admirable cause. And we're thrilled to participate in this because it's a very unique way. This is the first project that I've ever heard of using a solar array as a nonprofit revenue generator for community improvement. So I think it's something that should be awarded and should be replicated throughout the country. And we're hoping to see more projects like this. So we donated the inverters to them. Like I said, the modules were donated by First Solar, and Gem Energy donated the engineering work. And we're looking to add energy storage in the next few months here. So the system's built. They're about to do the witness test, and then the energy storage should come in the next few months here.
And do you know how big the storage is going to be on this?
It'll probably be like 2 megawatt hours. We're still figuring out exactly how big it's going to be and how much battery will be donated.
Yeah. I'd love to connect with Gem Energy. It's been a few years since we had any dialogue with them. They used to have a developer that was working in Illinois, so we're in the process of expanding our geographic footprint.
Excellent.
Today we work really primarily in Illinois. Tomorrow we'll be working in a much bigger geography so that we can avoid some of the ups and downs of the solar coaster. But we're looking at projects in New Jersey and Maryland, and hopefully going into Virginia as they see a real ramp up here in the next couple of years.
Fantastic.
Yeah.
This was Jonathan's favorite project.
It was. I always love when I can give things away for free.
It looks like a First Solar project. Is that First Solar solar panels?
Yeah. They donated the modules. Yeah.
So
Okay.
I think it's a it's a really, I think overall just a great feel good story. You know, American inverter manufacturer donates the inverters. American module manufacturer donates the modules, racking, the engineering work, and it all goes to it's all being sold again, as Eric said, to an American manufacturer who's building EVs, and then all the money goes and helps the local, you know, impoverished community. And it really doesn't get out. I don't think it gets any better than that. And just a great example of how solar can just help in so many ways. And Eric, as Eric said, we would love to see this replicated everywhere. And not that we want to give away inverters all the time, but we're always interested in any way that we can help give back to the community and help. And it was a really fun project to work on with Gem. Tim, more than happy to make a reintroduction with them if you'd like. And we're really excited. The project, there's a lot more nitty-gritty details to the project that we won't get into, but you know, FEMA was involved. The area, you can see it's built on a superstructure, so it's not in a floodway, but it's a flood spillway or something of that nature, and something like 2,500 dump trucks worth of soil had to be moved, and there's a lot of intricate, interesting things about this one, and it took a lot of work from everyone to have it all come together. But at the end of the day, it's already a huge success, and we're really looking forward to donating the energy storage inverters. We're going to donate them and the other components, and then we're working again with an actual battery company. We'll be donating the batteries. Gem again is donating all their engineering resources, and again, it's a real good feel good project, and it helps the people who need it the most.
That's cool. And it only took 5 years to develop this project, right?
Yeah. Yes.
Not quite that long, but it was a long time.
A good 3 to come to fruition from when it started to, yeah.
Yeah. So Jonathan pointed out the superstructure that the inverters and the transformer and the switchboard are located there, and that's because the project is in a floodway. So I don't know if you can see, there's a pile of rock there. There's a little river.
Yeah, I can tell it gets wet.
Yeah, it gets wet. So FEMA had to give approval to build in this location.
Mm-hmm.
And they submitted their application, and then a couple weeks later, I don't know, FEMA like all went on furlough from the last government shutdown. So the project was held on hold for quite some time, waiting for FEMA to come back into the office and you know, approve the project. So that was an exciting time. You know, when are we getting approval? When are we getting approval? But finally they got it, and they had to, you know, lift up some of the electrical equipment to keep it out of the water there. But that's one of the things that happens when you're working with land that's essentially been given to you for next to nothing. So I don't know what the lease was, but
it was zero.
Or I think it might have been like $1 for 20 years or something. So basically free, right? So
yeah. All right, I want to make a few announcements. Listeners can find us at cesnrg.com/podcast. We're dropping 2 videos a week now, so check out our YouTube channel. Give us a thumbs up, subscribe to the channel, make comments. We love to hear comments from our listeners, and please suggest future topics and speakers that you'd like to see come on the show. I'm Tim Montague, your host. Thank you so much, Jonathan and Eric with Yaskawa Solectria, DC coupled storage. Thank you guys so much. Have a great day.
Tim, thanks for having us on.
Thank you.
Today, DC coupled storage. I'm Tim Montague, your host. Today, we're interviewing Yaskawa Solectria. My guests are Jonathan Helmuth and Eric Every from Solectria, the inverter manufacturer. Welcome to the show, Jonathan and Eric. Today, DC coupled storage. I'm Tim Montague. Today, we're interviewing Yaskawa Solectria, makers of string inverters and central inverters. Today, DC coupled storage, pairing storage with your solar array. I'm Tim Montague, your host. Today, my guest is Yaskawa Solectria. Today, my guest is Eric Every and Jonathan Helmuth from Yaskawa Solectria. Welcome to the show, guys. Today, DC coupled storage and solar inverters. I'm Tim Montague, your host. Today, 1500 volt inverters and DC coupled storage. I'm Tim Montague, your host. Today, my guest is 1500 volt inverters and DC coupled storage. I'm Tim Montague, your host. Today, my guest is Yaskawa Solectria, the inverter manufacturer based in Massachusetts with manufacturing facilities here in Illinois. And they make the only true US-made inverter for the solar industry. And they've come out with a DC coupled storage technology. And I'm pleased to bring Jonathan Helmuth and Eric Every on the show. Welcome to the show, guys.